In this lesson, we're going to learn to predict the products of the condensation of amino acids, and we're going to look at how we name polypeptides given the abbreviations. We're going to look at the formation of a dipeptide because it's the simplest polypeptide containing only 2 amino acids. We're looking at alanine and serine. What small molecule is removed in a condensation reaction? Hopefully you remember that it's water. Remember that we also call those dehydration reactions. We know that water is being lost, so we're going to lose an OH from alanine and an H from serine. We could also lose an OH from serine and an H from alanine, but we're going to show it this way, although the other would be a different molecule, but it could still happen. Generally, it's easier to draw the groups that you're losing next to each other to make it easier to draw the new bond. Now that we remove the water, our OH and H, we're left with a carbonyl and the NH. And the new bond that will form will be between the carbon and the nitrogen. So our new bond forms between those. Remember, when you're looking at this, the OH is removed so that oxygen can no longer be involved in the bonding. What type of reaction occurs to form a dipeptide? I hope that you recognize that it was condensation. We have 2 amino acids coming together and losing water along the way, and that's the definition of a condensation reaction. Which atom on lysine, which is here on the left, will bond to the N-terminus on serine, which is on the right, to form a dipeptide? The thing we have to remember first is that we lose a water molecule. So the first thing I'm going to do is actually mark the atoms that I'm going to lose because I know that they can't be involved in the bonding. So in order to form the bond, I'm going to have to lose an OH and an H. So we'll only have 1 hydrogen left on the amine group. This NH2 cannot be involved in bonding because it's part of the side chain and it's never going to be there. My NH2 can't be involved because I can't have an amine group and an amine group bond together. So I'm left with 2 options, number 3 and number 4. Remember that when the condensation occurs, water is removed, which means this OH is removed from the molecule. So it is not there to form a bond. Therefore, this carbon, number 3, is where my new bond will form. And the bond will form between carbon and nitrogen. Which bond breaks when this dipeptide undergoes hydrolysis? The first thing we want to look for is the backbone. Remember that we can't actually have any hydrolysis occurring in the side chain. When bonds are broken or formed in the formation of polypeptides, it's always going to be within the backbone. So the first thing I want to do is identify the backbone, and I'm going to look for my pattern of NCC, NCC. So I have my amine group, my CH, my C double bond O, my amine group, my CH, my C double bond O. So I know that whatever bond that breaks is going to be within that backbone. That means I can eliminate several of these options. So it can't be 6, 7, 9, or 8 because those bonds are not in the backbone of the amino acid. And here we're going to think about 2 things. We're going to think about hydrolysis, and we're looking for that weak point where the bond can break. And we're also going to think about where the bond formed when we formed this dipeptide. And where that spot is right in here. So bond number 3. So we see the C double bond O in. We know that the CN is a weak point that we can break. And we also know that from this side, on the left of that blue line is 1 amino acid, and on the right is another amino acid. So that's where the bond formed to make the dipeptide, and that's where it's going to break to make the 2 separate amino acids again. We'll do a little bit with naming amino acids and naming those dipeptides, just so that you're familiar with the terminology when you see it in problems. There may be a few problems on sampling that have you write out the name. I will not ask you to write out names from scratch, but I do expect you to be able to recognize names on the exam and be able to match up a name with the amino acid or the peptide. So using our 3-character abbreviation, our name would be ALASER. If I look at this side chain, I can identify that as alanine using my reference table. I can identify this one as serine because, again, I use my reference table and I've identified my side chain. And so using the 3-character abbreviations, I get ALA-SER. The longer name for this, without the abbreviations, would actually be ALANYL serine. So alanyl serine. The one at the N-terminus gets changed to a YL ending, and then the second one stays the same. What is the name of the dipeptide using the 3-character abbreviations? The first thing we need to do is to figure out which amino acids went into making this dipeptide. So the first thing I'm going to do is figure out where the 2 amino acids are. I see my NCC backbone, and so I know that's where my amino acids divide. And then I have this side chain, and I have this side chain. So the next step is for me to look at my reference table and determine the identity of each of these amino acids. And when I look at the table, I see that the one on the left is tyrosine, and then the one on the right is lysine. I can also use the table to look up the abbreviation, so TYR and LEU. So my correct answer is TYR LEU for my abbreviation.